In this video, I'll be helping you with the ALEKS problem type called classifying conics given their equations. Here we're given equations for conics in general form, and we're classifying as either a circle, ellipse, hyperbola, or parabola. And actually I'll start with parabola because that will be the easiest one to identify in any form, because for a parabola, we only have an x that's being squared or a y that's being squared. And in both of these examples, there's both. So I know that these are not parabolas. But if I would have had one that only had an x squared or only had a y squared, I could have immediately identified it as a parabola, just as quickly as I have eliminated it here as a possibility. And from here, I'll just need to take each of these and start putting them in standard form to see where we end up. Starting with the first one here, A, to put these in standard form, I'll need to complete the square. And since both of my leading coefficients are positive, I'll start with the x's and group those together to be 3x squared minus 6x. And then I'll group my y's together, leaving a little space, 3y squared minus 6y. And then I'll move that negative 21 over to the other side as a positive 21. And from here I can start to complete the square. For the x's, I would first need to factor out the 3 to give a leading coefficient of 1. Factoring out a 3, I would have x squared minus 2x. For the second portion here, I would also be factoring out a 3, and this time y squared minus 2y equals 21. From here I can complete the square. Half of 2 is 1, and when I square that, it's also 1. I want to add 1 to make that a perfect square, but I have actually added 3, so I'll add 3 to the other side. For the y's, taking half of the middle term is again 1, squaring it is 1. I want to add 1, and again 3 times 1 is what I have actually done. I have added 3, so I must also add 3 to the other side. Now that I've completed the square, this first expression will be x minus 1 squared, a perfect square. And for the y's, I also have y minus 1 as a perfect square, equals, on the right-hand side, I now have 27. And from here, these leading coefficients are equal, so I can divide throughout each term by 3, and I will have x minus 1 squared plus y minus 1 squared equals 9. So this is addition in the center, so it's not a hyperbola. And since any fractional parts here would be the same amongst the x and y's, this hasn't been stretched to form an ellipse. This is just a circle. So A is a circle, and I can tell once I had it in standard form. Moving to B, we can still eliminate parabola as a possibility because we have both an x squared and a y squared term. And this time, as I start to move this into standard form, I notice that one of these squared terms is a negative. The x squared term is a negative. And actually from here, I can already determine that this is a hyperbola because it's the only one that had that negative in the middle once we had it in standard form. But in case that were not obvious, I'll go ahead and put this in standard form, and I'll start with the positive leading coefficient, which is our y's. So I would move those first as y squared minus 4y, and then I would have my x terms, so a negative 16x squared minus 64x. Again, I'm doing the x as second because that leading coefficient was negative. And I would still add this 76 to the other side. And from here, I'm almost ready to complete the square. For the y's, everything is set to complete the square. But for the x's, I need the leading coefficient to be 1. So I'm going to factor out a negative 16. That would give me an x squared, and then factoring out a negative 16, this would be a plus 4x equals our 76. Completing the squares, half of 4 is 2. 2 squared is 4, so we add 4. Nothing to distribute, so I must also add 4 to the right. For the x's, half of 4 is 2. 2 squared is 4. We're again adding 4, but this time there is a negative 6 that would get distributed to that negative 4. So I have subtracted 64 from the left-hand side. I must also subtract 64. And with these completed squares, I now have y minus 2 squared, a negative 16 in front of x plus 2 squared. And on the right-hand side, this simplifies to 16. For ellipses and hyperbolas, we always want our leading coefficients on the left-hand side to be 1. So to remove this 16, I need to divide each term by 16 on the left and the right. So standard form would have y minus 2 squared over 16. These 16s cancel. It's still subtraction, but my denominator is now 1. The right-hand side is 1 with this subtraction in the middle and 1 on the right-hand side. As we predicted earlier, this is a hyperbola.